Hello, so in this video I'm going to be going over the code and how to make a graph of one of the previous equations for heat and thermal diffusivity from the previous video. So I went ahead and imported all of the functions we will need. I imported numpy as np to import Python coding. And I also import this make subplots as we will be making a plot. So essentially what we are going to have as our givens is we are going to have alpha equal to 1. We are going to have the in increment equal to 50, which is the positional increment, like the number of positions there are. And we're going to have the t increment, which is the number of time increments we want, which we will have that equal to 2000. So we are going to hit Shift Enter. So far, so good. And what we are going to also have in this is we are going to have dx equal to 1. I did not want to. Okay. All right. I don't know why I did that. So we're going to have a variable dx equal to 1. We are going to have a dt equal to 0.1. And we are also going to have a value r, which is equal to alpha times dt divided by dx squared, in which dx is changed in x and dt is changed in time. So if we hit Shift Enter, still so far so good. So now we are going to have a variable t, capital T. No, it's capital. This is going to be for the temperatures. And we are going to have that equal to np full of the in increment. And we are going to have it 25. So pretty much what this did is we are going to have an array, which is t, for all the temperatures. And right now all the values are equal to 25. So now what we want to do is we want to kind of set the initial temperature and the ending temperature. So since in Python coding the array and list increments actually begin at 0, our first value is t0. So we are going to have t0 equal to 50. I don't know why it keeps doing that. It's getting annoying. And we are going to have the last increment okay, there we go, equal to 80. I think there's a way to escape that. So hit Shift Enter, and now if we see the T array, we can see our first value is 50, our last value is 80, and all the values in between are 25. So that's just kind of to make sure our array is looking fine. So now what we can do is we can start to make our figure. So we will do figure equals make subplots. Sorry. Rows equal to 1, columns equal to 1, and we will do figure dot add scatter, and we will have the x equal to the just x, and we will have y equal to t, and we will name it let's just call it initial conditions. So now what we want to do is we want to make a for loop, and so we will have for range no, that's not right. For I in range, there we go. So we'll have for I in range 1 to t increment, which is for each time increment. We will have, first we're going to have the list. So this is calling upon the array of the first value to the last value, since it's 1 to -1. And we will have that equal to t1 to -1 plus r times to t2. Forgot a colon there. Yes. And we will have that minus 2 times t. Where is it? There's the colon. 1 to -1 again. And finally, we will have plus t of colon to the -2. And we also want this little thing right here, which is kind of making sure we only get values that are whole 100s, because we don't want 2,000 things popping up. This will limit the number of things that will pop up on our graph. So we will want dig dot add scatter of x equal to x, y equal to t. We want the mode equal to lines, and we want the name equal f I. So now pretty much what this is saying is we want t in this range equal to t from second value to the last value, plus r, which again, r is right here. It's alpha times dt divided by dx squared. R times t of the third term on, minus 2 times t from the second term to the last term, plus t of the first term all the way to the second to last term. And again, this I %100 equals 0 means we are going to add to the scatter plot lines for all increments of 100. So if I hit Shift Enter, Hmm. Invalid syntax. I think maybe these are supposed to be squiggly brackets. No. It says something with the mode here. So. Yep. There it is, a comma. So for this, X is not defined. Oh, I forgot to define X. So, I meant to define a variable X, which we will have as np.arrange, and we will have in inc. Okay, I thought I typed something weird there for a second. And we will have times dx. So, yes. Oh, no. Let me see if I have to hit a shift enter on these other things. No, still not working. I see now. And that is why you don't type too fast. You misspell one thing. All right, so now we have no syntax errors. So let's see the figure. All right. So this is approximately what we should see. So we have a bunch of lines curving in. You can see our initial condition line, which we have them all equal to 25, and all of them start at 50 and go to 80. So now, if you play with the dt, you will see better lines at 0.5. You know, this is a very nice picture. But then if you go over 1/2, it freaks out. You know, we're getting values 3 times 10 to the 274th. I don't even know if that has a name, but I sure as heck don't know it. But then anything less than that, so let's really mess around with and add in a bunch of zeros to the 1. You don't notice anything changing. Maybe I added in too many zeros. let's start off with that. So even just 0.501, you can see some oscillating. And essentially what I will do in the next video is explain why when it's over 1/2, why it's so unstable.